So again, your script, yes. Yes, so your script should be, so this is a function, this is not a script, right? Your script should have asked at the beginning, please give me your volume, give me your array of heights, stuff like that. Now, if I wanted to modify that script into a function, here it is. I have to put function, of course, and I'm going to have surface areas as an output. And this function works with input v, and apparently it's uppercase V, and h. Now this is how it works. Number of arguments is number of arguments I'm calling this function with. So if I call my function with the following, I say v is 355, and I create myself h's as between 12 and 14, and I'm gonna, I don't know, okay, these are my h's. So I can just say beer of v and h, okay, and the function will execute. All right. Now, if I know that I want to have some certain default values, and I want function to work with those default values even if I don't enter anything, okay, I can program them in. So when I call function beer of vh, because my inputs are separated by comma, MATLAB knows that I called it with two arguments, two input arguments, okay? So when I execute this n argin, it's number of arguments input, n arg n, okay, is set to 2. Okay? If I call it with 1, it's set to 1. If I call it to 0 with 0, it's set with 0. Okay. Now, if I don't have this part here, my function is programmed to work with 2 arguments. If I have a function like this, and I call it with less than 2 arguments, let's say I just say beer, okay? MATLAB will yell at me, not enough input arguments, because it knows it's 0, that 0 is less than 2, what it should be. Okay? Now, how do I fix that? Tell myself, okay, if I'm lazy on Friday morning to type things in, then give me default values. Default value of v, default value of h, in case that number of arguments is less than 2. Or I could say here, it's 0. Okay. I could say also, if number of arguments is only 1, then I'm going to assume that the first one is volume, and I'm just going to create h. I decided to create h this way, not using linspace as most of you, just to be different. Okay. So now I actually have default behavior, and the function will execute fine if I enter no arguments, 1 argument, or 2 arguments. Yes? So if I enter 1 argument, it's going to come here and say, well, this is not, number of arguments is 1, so this is not going to execute. It's going to come here and say, oh, it is, number of arguments is 1, I'm missing heights, here they are, and then it can proceed and compute what it needs to compute. In case I entered both arguments, none of these will execute and everything is going to be fine. Yes? Questions? So this is, if you noticed, for instance, function plot works in all kinds of ways, right? It works if I just have 2 arguments, 3, 4, 5, and depending on what all I can add to it. That's how these functions are programmed, to be nice, essentially. I could have also done else if here. But I actually like it the other way. It's cleaner. At least it's cleaner for me to read. Good? All right. Everybody finished with these scripts? In general, do you have questions about loops, programming parts? What seems to be the most difficult part? Thinking the problem through? So that's one thing to actually, that part is still on you. What all of these if loops, for loops, while loops, they give you tools, but you have to put the tools together. So for that part, it's always a good idea to actually take a piece of paper and sketch what it is that you want to do. Don't be afraid of doing that, and kind of do a little bit of design on a piece of paper. Human brain, the way humans think, is actually working better when you take a pencil and write. Okay? So with a piece of paper, write. Don't expect to just like open up and start working in MATLAB from a blank screen. You can do that. It's going to be a little more difficult. And it appears that that's how I work, but note that I've been teaching this class for a while. So I've seen this Beer.m function that a number of times, and every year I actually recreate it again. Okay? So just don't think that that's how you should function. Take a piece of paper and jot down first, like organize your ideas. How are you gonna? And be modular. So work in, you know how to create surface area. Create yourself a function that computes surface area first, right? Even if you're not quite certain how the rest of it is going to look like. Because that will actually have, you will have one piece solved, okay? And then you can put it together. So just because you're confused about one part, don't let that block you working on different parts of the problem, because there's always multiple things in there. Okay? So now I'm actually just going to wrap up this programming part with comment on how to organize and debug your program. So this should all actually kind of sound familiar and just give, so we have gone through all of the major programming parts. All of these parts, we worked in MATLAB, but they're common to all programming languages, so you will just find them in slightly different syntax in other languages, so most of it will work. One thing that will not necessarily work in all of the languages is the vectorization part, the part where I can work with the entire vector. So that's really actually nice in MATLAB. Now, it's always, I've been mentioning that already, but it's important to kind of organize your code well and document it, especially if you expect to use it again later. Because trust me, 2 months from now, you have no clue what it is that you were doing here on Friday, February 16th. Okay, so that good design and like having enough notes in there makes it easier for you to use. Also, it makes it easier for you to share the code with others. Nothing really happens in isolation anymore. We're always part of a team. So if you're working on a project for, let's say, half a year and somebody else comes after you, they should be able to pick up. There should be enough reporting in there for them to be able to pick up your code and, you know, spend some time with it and figure out what's going on. So you're not doing things just for yourself, you're doing things to work with others, and you also expect others to do the same, so it's easier for you. Okay? So that part is that documentation that is not necessarily programming itself, it's actually working well in a team, and having in mind that we do forget and that we need to do things. So try to pick a style and kind of go with it. So for instance, naming of the functions, you might have a preferred way to make functions. I at some point actually decided to often, not all the time, use, so for instance, my surface area function could be something like this. It could be surface area. So some of my code is designed always like this, but it could be, but then let all your functions follow this rule. Okay? You can have multiple words, but the second word, the third word will be capitalized. Okay? But you could also adopt this. And that's fine too, but then let all of your functions be that way, especially in one folder. Okay? Because it's going to be easier for you to read and find things, and that's important. Also be generous in terms of naming things. So SA is great, except that a week from now you will not know what SA meant. Today you know it's surface area. Okay? So it's maybe short and practical for typing things in, but at the same time you have to kind of be somewhere in between practical for typing in and knowing what it means. So somewhere in there, there's a balance. It's never ideal. You shouldn't be like too long of a sentence for names, but at the same time, you should know what things mean. So one thing that we're going to always have is visually try to organize. So you will have certain blocks in your code. So there will be function part. There will be prologue part where you describe the function. Okay. Then you're going to process input. Try to process all of the input at the very beginning, not somewhere in the middle of the file. Okay. And then you're going to do some computational tasks and prepare output. Okay. So this should kind of logically always be how your functions work. You don't want to do input or process or asking for input in the middle of doing computation. That's calling for errors. Okay. So second thing is like you want to kind of use Whitespace. So both of these blocks here, both this one and this one, they're doing the same thing. It's a double for loop that is printing, I'm defining A, and then I'm basically printing all of the elements of A. Okay, nothing special here. But this one is way easier to read and spot what's wrong. Okay. Most of the time you will write a function and then 90% of the time will be spent figuring out what went wrong. And that's going to be easier if there is nice little indentation. Now, how much indentation, that's up to you. Okay? So that both of these codes work and they're correct. And as far as computer goes, they're just fine. It's not for computer. You're doing indentation for humans, not for computer. Also, this is the meaningful variable names. So it could be if you have thickness, then maybe thick is better than T. If you have inside and outside radius, then R in and R out are better options for naming variables than R and R2. Okay. So in that sense, it should be good. And then again, commenting, you always begin comments with a little %, and they're ignored by the program, but the more comments you have, the better. So here is one good example. Okay. This is statements at the beginning. So this is a professional looking prologue. Okay. This is a function that computes density of water given temperature and given the set of units. So this is stating what it does, density of saturated liquid water. Synopsis of the function is what are the different ways to call this function. So this one is probably using an argin, number of arguments, to work in a certain way. So it can work with no inputs. Okay? It could work with just temperature, in which case it figures out some default units, and it could work with both temperature and units. Okay? So this part tells me how I can call the function. And then after that, it explains what input should be. Both are optional parameters. So if I skip them, something will be a default. And default is set here to 20 Celsius degrees. So if I write help H2O density, all of this gets printed. And you've already noticed how good MATLAB is. Actually, it prints too much text. Most of us don't want to read 3 pages. Okay? But all of the information is there on how the function can be used. And then units could be F or C for Celsius, F for Fahrenheit, C for Celsius. Okay. And then output is density in this, but if units are Celsius, or British units if units are Fahrenheit. So this is pound mass per foot cube. And then there's some notes on where was this programmed. So this is a well-documented code that you and anybody after you can then refer to easily. Now, in terms of designing a numerical solution, the biggest problem you will have is actually going to be solving the problem. Okay? Designing the code and designing what needs to be done to actually solve the problem. Okay? And you just need to be familiar with all of the tools like for loops, while loops, and so forth that can help you in that. Okay? So you plan the solution kind of step by step, divide the program in pieces, work on the piece you know first, and that will kind of help propel you in solving the entire problem. Sometimes when you see one small piece like that surface area, you see it solved and you have it ready to use, then you kind of know what to do after that. Okay? So identify a piece you can work on immediately, even if you're completely puzzled about how to do everything else. And then you translate. So first sketch it on the paper and translate the code, and you also have to test the code. Okay? So let's say that this so-called top-down design is basically if you're going to plot the sine wave, then mentally say, okay, I have to generate myself a vector between 0 and 2p. Then I'm going to evaluate what I'm going to plot. Then I'm going to plot it. So sketching that and writing them down helps you also write the program. And you could also, depending on so here's the thing. It does help writing surface area in my code. When I see this, okay, in this function here, surface area is not a complicated function, okay? It's really one line. Technically, there's no need for having a separate function. However, I might expect, if I'm building a larger code, to use this surface area all over again. That it's actually useful to have a separate function in a separate file so that I can call it again from different other files, not just from this one. That's first thing. Second thing, when I'm actually walking through what is happening in my function, when I see this written as surface area, it's way easier for me to figure out what's going on. And that's useful. Okay? So in terms of like your functions are maybe simply because you create a separate function because it's going to be used by multiple programs, so it's good to have a separate function. Or it makes it actually easier to organize your code in separate units so that it's clear what is in there. Okay? So there's no correct number of M files or separate functions that you should have. You organize the code, you decide, or maybe if it's a test, I tell you what to do, right? And then I expect you to follow that because I'm simply testing whether you know how to do it. But in general, you will actually organize it yourself. Okay? And then in debugging, there are small bugs that are always the easiest ones are the ones where MATLAB complains immediately, then you immediately fix it. But sometimes there are hidden little things that are not working correctly, and you still have to find out why aren't they working correctly. It could be also simply a matter of design. So let's see this function z multiply xy. It's simply computing product of two variables, fine. Okay? But however, this is x times y. What if I give it, for instance, two vectors? It's not going to work correctly. Okay? So it doesn't mean that the function in itself is not correct. It's just that you're using it in a wrong way, which is where having basically product of two variables which are scalars would be helpful hint to have in there, right? So sometimes you will be actually fixing or adding to the functionality of the code that you have. It's not necessarily wrong. So expect to adapt the code as you go in. And this is where having proper prologue and everything would actually help, because then you would realize, oh, well, these need to be scalars, and you can then change the function to, for instance, work with vectors. Okay? So again, make sure that everything is working, and don't assume that the data that you have is working correctly. So you always be ready to test all parts of the code. And one would call this defensive programming, kind of always guard yourself against the input. So at the beginning, you might want to put certain checks with if else. Oh, is this input in the format I need it to be in? Because your program might actually survive and compute something, but that something might be garbage because you didn't put enough garbage. So garbage in, garbage out. There's no other way. Yeah? All right. All right. So I see you on Monday.